Hello, in this topic we will see the vertex form by completing the square. The formula of the vertex form is this one. Fx should be x minus 8, a number, to the power of 2 plus k. And the vertex will be 8, comma k. Be careful, it should be minus 8, so as to be 8, comma k. So for example, if I have this quadratic, x minus 2 to the power of 2 plus 3, then the vertex is 2, 3. If I have this quadratic, x plus 2 to the power of 2 plus 3, then the vertex is minus 2, 3. Let's clarify this case a little bit. This one, so as to write it in this form, is written x minus 2 to the power of 2 plus 3. So you see it's minus, and 8 is minus 2. So that's the case. Now the problem is that most of the times my quadratic is not given in this form and I must bring it. Now to do that, there is one simple step that you have to do. But before, I have to explain the perfect square formula, which is a plus b to the power of 2 is equal a square plus 2 times ab plus b square. And the other one, it's a minus b to the power of 2 equals a square minus 2a times b plus b square. So, for example, if I have the if I have to expand this perfect square, x minus 5 to the power of 2 is equal a square, so x square, minus 2 times a times b plus b square. So it is written x square minus 10x plus 25. Now you have to so as to complete the, so as to have here this form, to build that form, they will give me this form of the square and I have to go back to this. How I will do that? Let's say we have this quadratic function, which is x square plus 12x plus 15. Now, the first and most important part, so as to find the vertex form, the coefficient of x here, it should be always 1. If it's not 1, I cannot write it in a vertex form with this way. Now, which are the steps? First, I will take the first two terms, x squared plus 12x plus, I will leave some space, something, plus 15. Now this one, it should be written in the form of x, because I have plus here, plus something to the power of 2. So this one must be transformed in this form, a perfect square. Now how I will do that? Now you must have in mind always, in this case, that I always have to know this expansion of the perfect square, that it's a square plus 2 times a times b plus b squared, as the previous example here. Now, here, this is my first term, a term, and this is this term. So 2 times a times b is this term. So basically this one is written, it can be written 2 times a times, now how much is going to be b so as to give me 12x? 2x times 6. So you see, 2 times 6 is 12x. So b is this number here. But to complete the square, I must have plus b squared. So how much is b? 6. So it should be 6 squared. So how it can be before going to the next step. But listen now, in an expression of this one, I added here plus 6 squared. But this is not correct mathematically, because I cannot just appear a number like this, add a number like this. So I must also subtract this number, because 6 squared minus 6 squared is 0, so it's like I never put it. But what happens now, since I put it here, this is my perfect square, x plus 6 to the power of 2. If I'll expand it, it will give me this one. Now, plus 15 minus 36 is minus 21. So this is my vertex form. In which is the vertex? The vertex is going to be minus 6, 20 minus 21. Let's see another example so as to grasp it better. Fx is equal x squared minus 24x plus 3. Again, I have to take the first two terms. I will put them in a bracket so as to have clear my perfect square. Minus 24x plus 3. Now this one is always, basically you can find b if you will just divide by 2 the coefficient, and you will find it. But I prefer the method where I know what I'm doing. What does it mean? So this one is basically minus 2 times x times, so 2 times how much it will give me 24, minus 2 what it will give me 24, minus 12 times 12. So here is going to be 12 squared, and I must also subtract it. So the perfect square is x minus 12 square. And now 12 square is 144, minus 144 plus 3, minus 141. So my vertex is 12, minus 141. And that's how I write my quadratic in a vertex form here.